In this video, we'll use the general problem-solving strategy to solve linear equations involving fractions. So in this video, we're going to look at these three examples that you see on the screen. Let's begin with the first one. So we could use the same strategies for solving equations as we did in the earlier video. But when we have fractions, we can use a strategy to help us clear out those fractions so we don't have to do the addition, multiplication with the fractions, which can sometimes just take a little more time. So what you're going to do is take a look at the fraction that you have and focus on the denominators of that fraction. So in this first example, my denominators are 2, 10, and 5. So I want to find the least common denominator of those three numbers. So can also think about that as the least common multiple. So the least common denominator or multiple of 2, 10, and 5. So think of a number that all three of those numbers divide into. And in this case, the smallest would be 20. So 2 goes into 20 10 times, 10 goes into 20 twice, 5 goes into 24 times. If you can't find the least common denominator, you could just multiply the denominators together and use that. So we're going to take this common denominator and we're going to use it to clear out the fractions. We are not rewriting the fractions with the same denominator. We're actually going to get rid of all the fractions in the equation. So I'm doing that using the multiplication principle, which tells me I can multiply both sides of the equation by the same non-zero number. So I'm multiplying both sides by 20. I'm putting parentheses around my equations, or each side of the equation, to show that I am multiplying the entire thing, and I'll use the distributive property. You could also, just to remind yourself that this 20 is a whole number, and put it over 1. We're really only multiplying all of the numerators or integers by that LCD. All right, so first I'll multiply the 20 times the negative 1/2 y. I'm going to write this without simplifying first so you can see every single step, but you could eliminate the step I'm about to write. So 20 times negative 1 is negative 20. 1 times 2 is 2, and then bring down the variable y. Next, 20 times 4 is 80. So just distributed that 20 there. Bring down my equal sign. On the other side, I'm multiplying everything by 20 again, so 20 times negative 9 is negative 180. 10 times 1 is 10. Bring down the y. 2 times 20 is 40, so plus 40. 5 times 1 is 5. So now I still have fractions in my equation, but these fractions can all be simplified. And when I simplify them, I don't have a fraction any longer. I'll have actually all integers. So negative 20 divided by 2 is negative 10. So that term becomes negative 10y, and then plus 80 equals negative 180 divided by 10 is negative 18y, plus 40 divided by 5 is 8. So my equation now has no fractions in it. So just by that step, I've avoided having to do addition or multiplication or subtraction with fractions. So now I can proceed as I did before. I want to isolate the variable on one side and the constant on the other. So I will, let's say, add 18y to both sides. Those cancel. Negative 10y plus 18y is 8y plus 80. Equals 8 on the other side. Then I'll subtract 80 from both sides. So we have 8y equals negative 72. And then divide by the coefficient 8 on both sides. I'm just going to write this off to the right here. So 8 divided by 8 is 1. So I have y, or 1y, equals negative 72 divided by 8, which is negative 9. And again, you could go ahead and do the check by taking that negative 9, plugging it into the original equation wherever you see y. So multiply negative 9 times negative 1/2, add 4 to that, see what you get. then multiply -9 times -9/10, add 2/5 to that, and see what you get. And you should have the same thing when you do both calculations. Okay, let's go on to the next example, which you see on the page below. Let me just move this up a little bit. So this one's a little bit simpler. We have -12/13 equals 4x. Again, think about what you want to do. So I want to find x. What is happening to x? X is being multiplied by 4. So in order to undo that, I want to divide by 4. On the other side, I have a fraction. And when I divide a fraction by a number, I have to think about changing to multiplication and taking the reciprocal of my divisor. So what I could do is think about that from the beginning. So instead of dividing by 4, I could multiply by the multiplicative inverse of 4, and that would be 1/4. So I'm going to multiply both sides by 1/4. I'm going to write that in a different color here. So times 1/4, and then on this side, I'll put parentheses around this, and then a 1/4 out in front. And again, the whole reason for that is because 4 times 1/4, or you can think of that 4 as 4/1 times 1/4, is 4/4, which is 1. And that will make the coefficient for x 1. Alright, so since I have that property, that multiplicative inverse, I know that on the right-hand side here, I have x, or 1x, right? If you write the coefficient of 1 or don't write it, it doesn't matter. On this side, I will multiply. I have a positive times a negative, so I know my fraction will be negative. I'm going to, multiply and then simplify after. You could certainly simplify before if you are comfortable with that. As the 1 times 12 is 12, and then 4 times 13 is 52. So my fraction would be -12/52, but I can simplify that because 12 and 52 have a common factor of 4. So when I simplify, I still have a negative fraction. 12 divided by 4 is 3, and 52 divided by 4 is 13. So -3/13 is equal to x. And anytime you have a solution that is a fraction, we almost always keep it in fraction form, especially if that fraction has a decimal representation that repeats. We would prefer to write it in fraction form. It's just a simpler way to write it. So leave your answers in fraction form. Just make sure they're in lowest terms. Okay, the last example we have here has lots of fractions and also parentheses. So we're going to use the same strategy that we did with the first one, where we're going to find the least common multiple of the denominators, but then we have to think about how to use that when we have parentheses going on as well. All right, so I have this problem written down here. Again, we're looking for the least common denominator. My denominators are 5 and 10. So my least common denominator of 5 and 10, well, since 10 is a multiple of 5, I can use 10. So I'm going to multiply both sides of the equation by 10. However, when I do that, on the left-hand side here, I have parentheses. So let's think about what's going on. This 1/5 is multiplying everything within those parentheses. So when I multiply by the common denominator, 10, I'm only going to multiply the 1/5. If I multiply the 1/5 by 10, and I could write that as 10/1 just to remind me how to multiply fractions. If I multiply the 1/5 by 10, that 1/5 will carry that 10 with it when it distributes inside the parentheses. So I'm not going to directly multiply the 10 in the parentheses in the first step. I'm just multiplying the 1/5, and then that will do the job for me. On the other side here, I don't have parentheses, so I'm going to take every term. There are 3 terms here, and I'm multiplying them all by 10, or if I write that in fraction form, 10/1. So let's see what we get when we do that multiplication. Again, the whole point of this is just to clear out fractions. So 10 times 1/5. Well, I'm going to write this without simplifying first. So 10 times 1 would be the numerator, and then 1 times 5 would be the denominator. So I would have 10 over 5, which is 2. So the side becomes 2 times m minus 5. So I did that simplifying mentally before writing it down. If you're not comfortable with that yet, that's fine. You can write it out as 10 over 5. It just means you'll have one more line of writing than I will. I'm going to do the same thing on the other side. I'm only multiplying the numerators by 10. The denominator here is 1, so that's not going to change the denominators. So I'm thinking 10 times 3 is 30, divided by 5 is 6. So this is 6m. My next term, 10 times 10 is 10 times 1 is 10, divided by 10 is 1. So plus, I could write 1m, or I could just write m, it doesn't matter, I'll put a 1 there. And then finally 10 times 1, don't forget this last term, even though it's not a fraction, you still have to multiply everything on that side. 10 times 1 is 10, so plus 10. So now I have my equation, which doesn't have any fractions in it. So I can simplify each side of my equation, distribute here, 2 times m, and then 2 times negative 5, gives me 2m minus 10, equals, on this side I combine like terms, 6m plus 1m, 7m plus 10, and then I want to start to use the addition or multiplication principle to get the variable on one side and to get the constant on the other. So maybe this time I decide to add 10 to both sides. So that gives me 2m equals 7m plus 20. And then that means I have to get the variable on the left-hand side. So minus 7m, minus 7m, negative 5m equals 20. And then divide by the coefficient to get a 1m, so divide by negative 5, divide by negative 5. M is equal to 20 divided by negative 5 is a negative 4. So my solution here would be negative 4. And once again, you could take that value, plug it into the original equation, negative 4 minus 5, multiply by 1/5. Take note of what that result is. Go back here. Negative 4 times 3/5 plus 1/10 times negative 4, and then plus 1. And then when you combine those, you have the same thing that you have on the other side, and you should, in fraction form or a decimal form. If you're doing this in your calculator just to check, you can compare the decimals instead of writing in fraction form. That works as well.